Okay, I hope that I think the first part is over, input characteristics. I hope that everyone should understood. Isn't it? So what do you mean once again? In input characteristics, so by keeping the output voltage VC should be constant, by varying VB, and we are finding the IC value, isn't it? So by keeping the VB value in steps of 0 to some 0.5, 0.6 values, we are finding the input current IB. So that is called as input characteristics. In the input characteristics, gradually we are getting exponential curve. From that you have to find out the new voltage, isn't it? Then the second part of this experiment is called as output characteristics. So what do you mean by output characteristics? So while keeping input current IB should be constant, this IB. So we are going to take IB1, IB2, IB3. What about these values? You will take some IB value, you will take some 25 microamps or 50 or 100 microamps, like 3 different values, or you can take any 2 also. For example, due to the time factor, IB1 you can take 25 microamps, IB2 is equal to 50 microamps. Then you will take VC value by varying the VC output voltage. Then you will get output current IC. Then we can take the graph, plot the graph while taking IC on the y-axis and VC on the x-axis. You will get the nature of the graph. This is the nature of the graph. So what about you observe in the nature of the graph? You observe that by varying VC value in steps of 0, starting with this is 0 exactly. This point is a 0 value. So IC also 0 value. So here you can take, this is exactly as a 0 value. IC is also 0. Still we are increasing some value, 0 to 0.1 something values. So just like 1 or 2 values, just to observe that 0.1 maximum is a 0.2, almost should be 0 value. So after that what happens? Slowly, linearly is gradually increases. So after reaching what happens? This graph is parallel to the VC axis, x-axis. That means it is attained the saturation condition. So this is a saturation condition. So that means we will get the constant values. After 0.2 or 0.3 values, still you are increasing high values. You go for up to 5 volts, 6 volts, up to 10 volts also. So you will get this IC value should be constant. So there is no increment in the IC even though we are increasing the VC value. That is called as output characteristics. Now coming to the experimental part. So this is a circuit diagram. So what happens? For example, we have to take it to output characteristics. First IB must be constant. IB. First I will look at this IB value. I am going to take it say 25 microamps. 25 microamps. IB value should be, I am varying. Just some loose, check it, always check in the loose contacts. IB value. Look at this IB value. I am going to fix 25. So IB value should be 25.9 something as 25. So 25 microamps. IB is equal to constant. So IB is equal to constant. So what about in the output characteristics? IB value, the base current of the transistor must be constant. So in this case I am putting as a 25 microamps. Then what about? We are going to varying these values, VC value. Just that's what I am connecting. I am removing these connections. I am connecting for the VC because we have only 1 voltmeter. That's what I am connecting these changes. Now we are going to take the values accordingly. You can look at this. When IB is equal to 25 microamps already fixed, then VC value can start with 0. So I am starting with this VC value 0. Look at in the diagram. VC is equal to 0. What about IC? IC is also 0. But IB is equal to some constant value. Let us say at 25 or 26 microamps. When we are varying VC value, so IC is also 0. Still I am increasing. Just you can show here. Just a little bit I am rotating a fine value of this 12 volts DC supply. So just I put into So VC is equal to 0.1, I'm keeping 0.1. VC is equal to 0.1. Yes, look at this. IC is equal to 2.2. So VC is equal to 0.13 or 0.11. So IC is equal to 2.2 milliamps. So a little bit increases. Whereas 0, 0, whereas VC is equal to 0.1, IC is equal to 2.2. Similarly, you can increase. VC is equal to 0.2. So again we'll get 3.3 milliamps. IC is equal to 3.3 when VC is equal to 0.2. Then increase 0.3. So 3.3 only, it is constant. That means is automatically where VC of 0.3 volts, it attains the saturation region. That must be constant. That is 3.3 milliamps. Still we are increasing 0.3, 0.4. 3.3. 0.5 is also 3.3. You can look at this 0.5 or 0.6. IC will be constant. Still 0.67 or 0.6. 3.3. That means it is constant. Then 0.7. So like that you can go for 1, 2, 3, 4. Isn't it? So go maximum value you can go it up to. So 3 volts. Go even it is a 3.3. Isn't it? So this is the values. This is the values. Look at this in the graph. This is the graph. Values we are going to take. This is the values we are going to take. These values. So look at this. By plotting the graph, you are taking VC will be in the x-axis, IC will be in the y-axis. So just you can 0, 0 value. VC is equal to 0. IC is also 0 value. IC is also 0 value here. The VC is equal to 0. So IC is also 0. A little bit increasing, but because in this case, what is the value? Even 0.5 is also 0. Even 0.1 will get some value. Just nearly about will get some 3.3 value. Then after that, so we can reaching some constant. So exactly at 0.3 volts, isn't it? 2.3, whatever the values. So we'll get all these points. Still we are increasing VC value, some 0.3 something, 0.4, 0.5 or 1, 2, 3, go up to 5 also. Just I am showing 5. It should be constant. What the values you are taking, so it should be a constant. So when IB is equal to 25, so 25 microamps. So we are plotting the graph VC on x-axis, then IC value, that's a collector current, and the y-axis will get this nature of the graph. So this graph I think exactly in our manual is given, exactly this one. So this is our saturation point. That means we will get some 3.3, isn't it, milliamps throughout the graph. Even you are increasing after 0.2, you go up to 5 volts, you will get the current must be constant. That is IC must be constant. So this is called as output characteristics. Once again I am telling you what you mean by output characteristics. So while keeping input current, that is the base current IB should be constant, like 25 microamps, or IB is equal to 50 microamps. So just you can take the observations, that is the output voltage, that is VC on the x-axis, and collector current IC on the y-axis. We will get this type of nature of the graph. So this is called as output characteristics of a graph. So like that you can find out from this graph what you observe that, isn't it? So you can find out the current gain. Current gain should be, you should calculate. So what about current gain? So this is a change in the collector current to change in the base current. That is, so delta IC by delta IB. So delta IC means IC2 minus IC1. So this is a, you can take IB1 is equal to 25 microamps, IB is equal to 50 microamps, isn't it? This is a IB1, this is IB, IB2 minus IB1. So IB2 minus IB1 means, so 50 microamps minus 25 microamps will get, whereas IC1 minus IC2, maybe in the graph you observe that this difference, therefore this is IC1, this is IC2, the difference of this, so IC2 minus IC1, these values you can get it. This is your IC 1. This value, exactly the peak value of this one is a IC2. IC2. So IC2, this value nearly about 9.5 minus this is exactly about 4. So this difference. So that's what you can observe in the calculation part. So IC2 minus IC1 will take from the graph, isn't it? IB2 minus IB1, already you know that, 50 minus 25. So we will get a current gain. So this is one of the important to the characteristics of a transistor, current gain. That is, change in collector current, output current to input current is called as current gain. Isn't it? So like that you can find out the current gain. Then finally you can find out the current amplification factor alpha. So whatever is very very important, collector current amplification factor alpha is equal to beta by 1 plus beta. The beta is called as current gain. Already might be you know that beta value. So beta by 1 plus beta will get a current amplification. Why it is called as amplification? The one of the main application of a transistor is it is acting as an amplifier. It is acting as an amplifier. So what do you mean by amplifier? So what about the amplifier? Is a device where we are giving a small signal at the input will get a strengthened signal at the output. So that is called amplification. Here our NPN transistor, or you take a PNP transistor, whatever may be, these transistors can be acting as a amplifying devices. So like that in this experiment all the students are able to learn to study the input as well as the output characteristics. Once again I am telling you, so input characteristics means the left part of the circuit by keeping VCE, isn't it? By varying VBE and we take as a IB value, that is called as a input characteristics. Whereas output characteristics means by keeping IB value, that is the base current should be constant. Let us say 25 microamps and 50 microamps, you have to vary with VC value in steps of 0 to 5 volts. Then we will find out the IC value. Then we will plot the graph while taking VC on the x-axis and IC on the y-axis. So at different constant base voltages, that is called as output characteristics of a transistor. Then finally result. So this is a table of you observe that you should find out the new voltage. So this new voltage you have to find out from your input characteristics. So on the input characteristics you will get some linear graph. You take a tangent, isn't it? So where the tangent is cuts on the x-axis. So that's what you can observe. So in this graph, so this is a new voltage. Exactly, this is a new voltage. This is called as a new voltage. The new voltage you can find out from this graph, input characteristics. Whereas input resistance also, already I told that. So from this you take any 2 points, you can take a slope. You can take a slope. So delta V by delta IB. So delta VB by delta IC. So we will get the resistance. That is called as input resistance. Then we will get input resistance. Then current gain beta. Already I am just now I told that from the output characteristics I have to calculate the beta value, isn't it? Delta IC by delta IB will get current gain. Then current amplification factor, that is alpha is equal to beta by 1 plus beta, that will get a 0.99 in this case. So the amplification factor of NPN transistor is nearly about 1. So should not get more than 1. There is important precaution. Everyone should keep in mind that the amplification factor of transistor is nearly about 1. So this is our transistor characteristics. From the transistor characteristics you have to study input as well as the output characteristics. From these characteristics you have to find out the new voltage and also input resistance and your current gain and amplification factor. Okay, any doubts? You can ask. Thank you.